Look up on a crisp winter night and you'll spot Orion, the great hunter, standing tall among the stars. For centuries, this constellation has been a familiar sight, guiding travelers and inspiring storytellers across the world. Orion is instantly recognizable by his three-star belt, a straight line of bright jewels in the sky, and the sword that hangs below it, shimmering faintly in the darkness. But it's on his right shoulder that something truly remarkable blazes. Betelgeuse, a brilliant reddish star that stands out from the rest. Betelgeuse isn't just another point of light in the sky, it's a colossal, dying giant, nearing the end of its life in a way that promises a spectacular finale. Its ancient name and fiery hue have inspired countless myths and legends for millennia. Ancient cultures saw Betelgeuse as a sign of power, a celestial omen. But today, science reveals an even more dramatic story unfolding. Finding Betelgeuse is easy, even for beginners. Just locate Orion's belt, the 3 stars in a row that cut across the hunter's midsection. Then, look up and to the left for a warm orange-red glow. That's Betelgeuse, shining like a cosmic ember on Orion's shoulder. It forms one corner of Orion's distinctive rectangle, directly opposite the blue-white star Rigel, which marks the hunter's foot. Together they frame Orion in a dazzling display of color and light. In recent years, Betelgeuse has captured the attention of astronomers and skywatchers alike by dimming and brightening in unpredictable ways. These changes have sparked excitement and speculation that its dramatic end could be closer than we think, at least in cosmic terms. If Betelgeuse does explode as a supernova, it will outshine every star in the night sky, possibly even visible during the day. A once-in-a-lifetime spectacle in our own galactic neighborhood. Stargazing at Betelgeuse is more than a pastime. It's a front-row seat to a cosmic story unfolding in real time, a reminder that the universe is alive with change and wonder. This star is a living drama, written in the language of physics across the vastness of space, inviting us to look up, to wonder, and to witness the universe's grandest stories as they happen. Betelgeuse is a red supergiant, one of the most awe-inspiring and mysterious stars in our galaxy. Its name comes from Arabic, meaning the hand of Orion, and it marks the shoulder of the famous Hunter constellation. For centuries, Betelgeuse has captured the imagination of astronomers and stargazers alike, glowing with a distinct reddish hue in the winter sky. It's not just any star. Betelgeuse is one of the largest stars in the universe, a true cosmic giant that dwarfs most others in both size and luminosity. If Betelgeuse were to take the place of our Sun, its vast surface would stretch far beyond the orbits of Mercury, Venus, Earth, and Mars, possibly even reaching as far as Jupiter. Our entire inner solar system would be swallowed up inside its fiery embrace. Its immense size is almost impossible to comprehend. Our Sun, which seems so massive to us, would be reduced to a tiny speck, barely noticeable within Betelgeuse's colossal volume. Betelgeuse glows a deep, fiery red because it's much cooler than younger blue-white stars. This color is a telltale sign of its advanced age and the changes happening within its core. As Betelgeuse aged, it expanded dramatically, swelling to hundreds of times its original size and cooling as it entered the twilight years of its life. This transformation is a natural part of a massive star's evolution. Despite being over 600 light-years away from Earth, Betelgeuse shines as one of the brightest stars in our night sky. It pours out thousands of times more energy than the Sun, making it a beacon visible even to the naked eye. Its surface is a roiling sea of turbulence, with gigantic convective cells, some as large as the distance from the Earth to the Sun, churning and bubbling, causing its brightness to fluctuate unpredictably over time. This variability is more than just a spectacle. It's a vital clue to the powerful instabilities and complex processes happening deep within Betelgeuse's core, where elements are forged and energy is unleashed. Betelgeuse is burning through its nuclear fuel at a breakneck pace, fusing heavier and heavier elements as it races toward its inevitable dramatic finale, a spectacular supernova explosion that will one day light up our skies. For now, Betelgeuse stands as a fascinating, unstable giant, an ever-changing star on the brink of a cosmic transformation, reminding us of the incredible power and beauty of the universe. Our Sun is a stable yellow dwarf, a star that quietly burns in the vastness of space, providing a steady and reliable source of energy for our solar system. Its gentle golden light has shone down on Earth for over 4.5 billion years, nurturing the planet and everything that lives upon it. The Sun burns hydrogen steadily for billions of years, a marathon runner among stars, pacing itself for the long haul. This slow and consistent fusion process is what makes our sun so dependable, allowing it to shine with a constant brightness that rarely falters. This remarkable stability has allowed life to flourish on Earth, creating the perfect conditions for oceans, forests, and all living creatures to evolve and thrive. Without such a steady star, life as we know it might never have emerged. Betelgeuse, by contrast, is a sprinter, born with about 20 times the sun's mass. It's a red supergiant, a true cosmic heavyweight, and its story is dramatically different from our sun's. More mass means more gravity, which forces Betelgeuse to burn its fuel much faster. Its immense size and power come at a cost, a much shorter, more turbulent life. While the sun will live for about 10 billion years, Betelgeuse's life is just 10 million years, 1,000 times shorter. In cosmic terms, Betelgeuse is a brilliant flash, while the sun is a slow, enduring glow. Betelgeuse's surface is restless, with giant convective cells and turbulent storms that dwarf anything seen on our sun. Its outer layers pulse and shift, making it one of the most variable and fascinating stars in the night sky. The sun's end will be gentle. After billions of years of steady burning, it will eventually swell into a red giant, expanding far beyond its current size. It will shed its outer layers into space, creating a beautiful planetary nebula that glows softly for thousands of years. What remains will be a white dwarf, a dense Earth-sized ember that will slowly cool over billions more years, quietly fading away. Betelgeuse's fate is far more violent and spectacular, destined for a dramatic finale that will outshine entire galaxies for a brief moment. As it runs out of fuel, gravity crushes its core, igniting new fusion stages, helium to carbon, then carbon to neon, and so on, each stage shorter and more intense than the last. These rapid-fire fusion reactions build heavier and heavier elements, racing toward an inevitable end. This process continues until its core is iron, the heaviest element that can be formed through fusion in a star's core. Iron fusion doesn't release energy, it consumes it, robbing the star of the pressure it needs to resist gravity's relentless pull. When Betelgeuse's core becomes iron, the star's life support ends. The core collapses in a fraction of a second, triggering a shockwave that tears the star apart. The stage is set for a cataclysmic explosion, a supernova that will briefly outshine the entire galaxy and send heavy elements hurtling into space. Massive stars like Betelgeuse live fast, die young, and go out in a blaze of glory, their deaths marking some of the most energetic events in the universe. Their violent ends scatter the building blocks of planets, life, and even future stars, shaping the universe in ways our sun never will. A supernova is the explosive death of a star, briefly outshining an entire galaxy. It's a cosmic firework, releasing more energy in seconds than our sun will in its lifetime. Supernovae are crucial. They forge and scatter the elements needed for life. Betelgeuse will end as a Type II, or core collapse, supernova. As it fuses heavier elements, its core becomes iron. Fusion stops, gravity wins. The iron core collapses in less than a second, forming a neutron star. The outer layers crash inward, rebound off the neutron core, and blast outward in a titanic explosion. The shockwave rips the star apart, hurling enriched material into space. This is the supernova we'd see, a brilliant flash marking the death of a giant. It's the universe's way of recycling stardust for new worlds. Deep inside Betelgeuse, gravity and fusion have battled for millions of years. Fusion pushes outward, gravity pulls inward. This balance keeps the star stable. But for Betelgeuse, this balance is fleeting. It burns through hydrogen quickly, then fuses heavier elements in ever shorter phases. The final act, an iron core forms and fusion halts. Gravity takes over, collapsing the core almost instantly into a neutron star. The outer layers crash in, rebound, and create a shockwave. This shockwave tears the star apart in a spectacular supernova. The explosion scatters the elements forged in Betelgeuse across the galaxy. The death of Betelgeuse is both an end and a cosmic beginning. If Betelgeuse explodes, Earth's sky will be transformed. A brilliant new point of light will appear, possibly rivaling the full moon in brightness. It will be visible even during the day, casting shadows at night. For weeks or months, Orion's shoulder will blaze, captivating the world. The supernova's glow will slowly fade, leaving behind a ghostly remnant. Telescopes will watch the expanding cloud for centuries. This event would unite humanity in awe, a shared cosmic spectacle. It would inspire art, science, and wonder for generations. The story of Betelgeuse's explosion would be told for centuries to come. Should we worry about Betelgeuse's explosion? Not at all. At 640 light-years away, we're perfectly safe. The vast distance shields us from harmful radiation. By the time any X-rays or gamma rays reach Earth, our atmosphere absorbs them. The kill zone for a supernova is about 50 light-years. Betelgeuse is far beyond that. We'll witness the beauty without any danger. No harm to satellites, power grids, or life, just a spectacular show. It's a rare chance to see the universe's power up close, but not too close. We are safe spectators to one of nature's greatest dramas. For scientists, Betelgeuse's supernova would be a once-in-a-lifetime event. Most supernovae are distant and faint, but this one would be in our cosmic backyard. We could study it in unprecedented detail, testing our theories about stellar death. Neutrino detectors would light up hours before the explosion's light reached us, offering a rare glimpse into the core collapse. Telescopes worldwide would capture the explosion across the electromagnetic spectrum. Spectrographs would reveal the elements forged inside Betelgeuse. We'd witness the universe creating the building blocks of planets and life. This event would revolutionize our understanding of how stars live and die. It's a front-row seat to the universe's most dramatic process. Stargazing connects us to the cosmos and our own origins. Betelgeuse's story is the story of creation and destruction that shapes the universe. Stars are born, live, and die, some gently, some in spectacular explosions. Betelgeuse's supernova will enrich the galaxy with heavy elements. The atoms in our bodies were forged in ancient stars like Betelgeuse. We are, quite literally, made of stardust. Watching Betelgeuse is witnessing our own creation story. Its fate inspires us to ask big questions and explore the unknown. The next time you see Orion, remember the journey and destiny of that red star. Looking up is an act of discovery, a reminder that we are all part of the universe's grand adventure.